Dear friend, welcome. So let's continue with our basic arithmetic series. In this session, we are going to talk about equivalent fractions, cancellations, and lowest term of fractions. So some fractions represent the same number. One example is 2,639,5/15, and we have more, have 10/30. We have plenty of them. We have 60/180. And they all represent the number of the fraction 1/3. So 1/3 is equal to 2/6. 1/3 is equal to 3/9. 1/3 is equal to 5/15, and so on. A close look at these numbers reveal that they share a property, and in this case, each fraction has a denominator that is exactly 3 times the numerator. So for 2/6, we see that 2 times 3 equals 6, right? For 3/9, we see that 3 times 3 equals 9. For 5/15, we see that 5 times 3 equals 15, so on with all other things. So the property here is that the denominator is 3 times the numerator. And the simplest fraction with this property is 1/3. 1/3. So the first thing that we have to know is that fractions are equivalent when they represent the same number. And from our previous listing, 2/6 and 60/180, for instance, are equivalent because they all represent the number 1/3. So 2/6 equal to 60/180 equal to 1/3. At this point, we know the meaning of equivalent fractions. So now the question is, how do I recognize when two fractions are equivalent? And for now, the answer will be short, and we will explain better later. So for now, to determine if two fractions are equivalent, write both fractions one in front of the other on the same line. So if I have fraction a over b and the fraction c over d, I write it like this, and I cross multiply them. So cross multiply is I take the numerator of one fraction and I multiply with the denominator with a second fraction. So numerator and denominator multiply. So cross multiplication of them will give me a times d. I will have an answer, and b times c, and I will have an answer. So if these two answers are equal, then my two fractions are equivalent. Otherwise, they are not. Let me rewrite it. A over b equal means equivalent to c over d if and only if a times d equal to b times c. So we cross multiply them, and this is a general formula. We know that denominators have to always be different from 0. So let's use two fractions from our previous listing for examples. And we have 2/6 and 5/15. question is, are these two fractions equivalent? Are they equal? So we don't know yet. How do we verify? How do we solve it and finally find a conclusion? So we cross multiply. So the first thing we will do is 2 times 15. Cross multiplying, we multiply these first, and we have 2 times 15, which is 30. And then we multiply this second. 6 times 5 equal to 30. So 30 equal 30. So this means 2 times 15 equals 6 times 5, right? So once we have this same result, we can conclude that yes, 2 6 is equivalent to 5 15. So another random example, let's take 1/2. Is this equivalent to, when I put question mark, is means I don't know yet, right? To 25 over 50? Yes or no? So to solve, we do cross multiplication. The numerator of the first fraction, which is 1, multiplies the denominator of the second fraction, which is 50, and 1 times 50 is 50. So we take the denominator of the first fraction, which is 2, we multiply by the numerator of the second fraction. 2 times 25 is 50. So we have same result, 50 equal 50. So yes, these two fractions are equivalent. Another example, 1/4. Is it equivalent to 29? Yes or no? We do the same thing. We take the numerator of the first fraction, which is 1. We multiply by the denominator of the second fraction, which is 9. Cross multiplication, this, right? And we have 1 times 9 is 9. We have to do same thing for this one. 4 times 2 equal 8. Here we have two different results. 9 is different from 8. So no, no, these two fractions are not equivalent, right? From what we saw so far, if we have been given a fraction, we can generate few other fractions that are equivalent to the given one. And how do we do that? Let's do it using the following example. Given the fraction 1/2, to find the equivalent fraction of 1/2, we will multiply the numerator and the denominator of the given fraction, which is 1 over 2, mm, by a same whole number different from 0. So let's go. Some equivalent fraction of 1 over 2 are, if I 1 over 2 times 8 times 8, 8 over 16 times 3, 3. So you have 3 over 6. We said we multiply top and bottom with the same number. So let's keep going. 1/2 times any random same number, 30, multiplied by 30, and we have 30 over 60. And one more, 1/2 times 25 times 25, and we have 25 over 50. So all these results right here are equivalent to my original fraction 1 over 2. So to find the equivalent fractions to a given fraction a over b, we just multiply both the numerator and the denominator by a same non-zero number c, right? So c is a non-zero number. We multiply, and this is the general formula. So we multiply the numerator by c, and we multiply the denominator by c, c being the same number and different from zero, correct? So now let's talk about cancellations and lowest term. The previous formula that we saw is about how to find the equivalent to a given fraction. And the formula is multiplying the terms of the given fraction by a whole number. Let's say a over b, which is the given number, and we multiply by a whole number, top and bottom, c. And this was the formula that we had. And this result, a times c over b times c, can produce equivalent fraction with higher terms. That means the result, the terms can be greater than the original fraction. So now the process of going from a fraction with a higher term to its equivalent of lower term is called cancellation. So when we move from higher terms to lower terms, we are talking about cancellation. To do that, we first check if both numerator and denominator have a common factor, which is a whole number greater than 1, which divides them both without having a remainder or remainder equals 0, the same thing. So once we identify the common factor, we cancel it top and bottom. Remember, our goal here is to lower the fractions term. So let's take an example of 15, this is 5 over 25. 15 and 25 can both be divided by 5 with 0 as a remainder. So what do we do is 15 over 25 is equivalent to 15 divided by 5, 25 divided by 5, and the result is 3 over 5. So 15 over 25 is equal to 3 over 5. Before we stop, we have to check, can 3 and 5 be divided by another same number greater than 1? No. So we stop here, and the final answer is what we have here. So let's do more examples. So find the lower term for the fraction 5 over 10. So how do we do this? 5 over 10. What is the common factor that we have here? We identified 5. So we can divide 5 by 5, and we can divide 10 by 5. Same number, 5, 5. And our result is 5 divided by 5 is 1. 10 divided by 5 is 2. All right. Another example, can be asked as reduce the fraction 28 over 70 to the lowest term. So how do we do this? Let's write, this is our answer. Let's write our fraction 28 over 70, and let's identify what is a common factor for our fraction. And we see that we can divide both numbers by 7. So let's do that. We do 28 divide by 7, 70, divide by 7. And what do we have? 28 divided by 7 is 4. 7 divided by 7 is 10. Okay, so this is a lower term, but is it the lowest? Meaning, can we reduce more our fraction 4 over 10? Each time you want to stop and say, this is my final answer, try to check if you can reduce more. If you can't, then this is your final answer. But if you can reduce more, then keep reducing until you can no more reduce. And then you will call it your lowest terms. So let's see, 4 and 10, can we reduce? Meaning, do we have a common factor for these two numbers? And the answer is yes. And what is the common factor? Let's rewrite this here, 4 over 10. And the common factor is 2. We can go divide 4 by 2. And we can divide 10 by 2. And we have 4 divided by 2, 2. 10 divided by 2, 5. So we have another result. And we have to check again. Can we reduce 2 over 5? Do we have any common factor for 2 and 5 that is different from 1? And the answer is no. So that means we stop. We cannot go further. We cannot reduce 2 over 5 further. So our answer, 28 over 70, is equivalent to 2 over 5. And 2 over 5 is the lowest term because from 2 over 5 we cannot go lower. Okay, so we stop here for this session as well. And if there is something that you don't understand, you can ask in the comments, and we will answer. And see you soon.